right, slide 1, plate tectonics. This slide introduces the theory of plate tectonics. Earth's outer shell, the lithosphere, is broken into large pieces called plates. These plates float and move slowly on a softer layer called the asthenosphere. Their movement causes earthquakes, volcanoes, mountains, and oceans. Think of Earth's surface as a moving puzzle. Slide 2, major tectonic plates. Here we see the names of the biggest plates: Pacific, North American, South American, Eurasian, African, Australian, and Antarctic. Imagine these plates as giant rafts drifting on molten rock beneath them. This slide's plate boundaries. This slide explains where plates meet, called boundaries. So, convergent, plates move towards each other. Divergent, plates move apart. Transform, plates slide past each other. At boundaries, Earth's surface changes the most. Other slide 4, convergent boundaries. Plates collide. Example, the Himalayas formed when the Indian plate hit the Eurasian plate. Results, mountains, volcanoes, earthquakes, deep ocean trenches. Imagine 2 cars crashing. Energy is released, just like plates colliding. Slide 5, divergent boundaries. Plates move apart. Magma rises and forms new crests. Results, rift valleys, mid-ocean ridges, new ocean floor. Like pulling apart bread dough and seeing new material rise in between. Slide 6, transform boundaries. Plates slide past each other and no new crests form. Causes powerful earthquakes. Example, San Andreas Fault in California. Seven, continental drift theory proposed by Alfred Wegener in 1912. All continents were once joined in Pangaea. Over time, they drifted apart. Evidence, matching coastlines, fossils, rocks. Limitation, Wegener couldn't explain how continents moved. Okay, later, plate techniques gave the answer. Layers of the Earth, crust, then outer layer. Mantle, thick, hot layer beneath. Core, center of Earth, inner solid, outer liquid. Asthenosphere, weak zone in mantle where plates move. Earth is like a layered cake, each layer with a special role. Atmosphere. Earth is surrounded by gases called the atmosphere, divided into 5 layers. 1, troposphere, weather, clouds, life. 2, stratosphere, ozone layer protects us from UV rays. 3, mesosphere, meteor burn here. 4, thermosphere, auroras, satellites. 5, exosphere, outermost, merges into space. Without the atmosphere, life couldn't exist. Ring of Fire, a horseshoe-shaped zone around the Pacific Ocean. Has 75% of volcanoes and 90% of earthquakes, caused by plates sinking under others' subduction. It's Earth's most dangerous zone. The Ring of Fire is a huge horseshoe-shaped zone around the Pacific Ocean. It's famous because most of the world's volcanoes and earthquakes happen here. But why? Let's break down the 3 main causes shown in this slide. At the edges of tectonic plates, one plate often slides beneath another. This process is called subduction. In the Ring of Fire, oceanic plates sink beneath continental plates. When this happens, enormous pressure builds up deep underground. Think of it like one piece of cardboard being pushed under another. The edges bend and crack, releasing energy. And 2, volcanic activity. When a plate sinks into the mantle, it gets very hot and starts to melt. The melted rock, called magma, rises towards the surface. When it escapes through cracks, it causes volcanic eruptions. So volcanoes form along these subduction zones. That's why countries like Japan, Indonesia, and Chile have so many volcanoes. As plates compress and slide, they don't move smoothly. The friction between them causes sudden jolts. These are earthquakes. The Ring of Fire experiences frequent and powerful quakes because of this constant movement. Imagine rubbing two rough stones together. They stick, then suddenly slip. That's what happens with tectonic plates. In summary, the Ring of Fire exists because of subduction, magma formation, and plate movement. These three processes together make it the most active geological region on Earth. All right, class, let's carefully go through this slide titled Types of Weathering. What is weathering? Weathering is the process that breaks down rocks into smaller pieces. It doesn't move the material, that's erosion's job, but it prepares rocks for erosion by weakening them. The slide shows us the three main types of weathering: physical, chemical, and biological. Let's explore each one. Physical, mechanical weathering. Rocks break into smaller fragments without changing what they're made of. Examples: exfoliation, outer layers peel off due to temperature changes. Frost action, water freezes and cracks, expands and breaks the rock. Abrasion, wind or sand rubs against rocks, wearing them down. Key feature, driven by temperature changes, pressure release, and mechanical forces. Imagine a cookie breaking into crumbs. It's still the same cookie, just smaller pieces. Chemical weathering, chemical reactions change the minerals inside rocks, forming new substances. Examples: carbonation, rainwater dissolves limestone. Oxidation, iron-rich rocks rust when exposed to oxygen and water. Key figure involves water, oxygen, and carbon dioxide. Creates cavities, sinkholes, and weakens rocks. Think of it like milk turning sour. The substance itself changes. Biological weathering process, living organisms break rocks physically or chemically. Examples: plant roots grow into cracks and split rocks apart. Burrowing animals loosen soil and rock. Lichens and microbes release acids that dissolve rock. Key feature combines both physical and chemical effects caused by living things. Imagine a tree root slowly pushing through a wall. It cracks and weakens a structure. In summary, physical breaks rocks into pieces. Chemical changes rock composition. Biological, living things help break rocks. Erosion. Erosion is a process where soil, rocks, and other surface materials are worn away and moved from one place to another. Unlike weathering, which only breaks rocks in place, erosion actually transports the broken pieces. Think of weathering as breaking a cookie into crumbs, and erosion as sweeping those crumbs away. The forces of erosion that carry away materials are called agents of erosion. Water, rivers, rain-watering waves wash away soil and rocks. Wind blows sand and dust, shaping deserts. Ice, glaciers scrape and drag rocks as they move. Waves constantly erode coastlines. Each agent acts like a natural vehicle, moving Earth's materials around. How erosion happens. It occurs almost everywhere and all the time. Sometimes it's slow, like gentle river flow shaping valleys. Sometimes it's rapid, like landslides or floods. Over time, erosion changes landscapes dramatically. Mountains wear down, valleys deepen, and beaches shift. In summary, weathering breaks rocks, erosion moves them. Together they reshape Earth's surface continuously. Factors influencing erosion rate. What does it mean? Erosion is a process where soil, rocks, and sediments are carried away by agents like water, wind, and ice. But erosion doesn't happen at the same speed everywhere. This slide explains the factors that control how fast or slow erosion occurs. Rainfall. Heavy rainfall increases erosion because water washes away soil and rocks. Areas with frequent rainstorms lose soil faster than dry regions. Example: flood-prone river valleys experience rapid erosion. Temperature. Extreme heat and cold cause rocks to expand and contract, making them weak. When rocks weaken, erosion agents like wind and water can carry them away more easily. Example: in deserts, hot days and cold nights break rocks quickly. Slope of the land. Steep slopes equal faster erosion because gravity pulls materials downhill quickly. Gentle slopes equal slower erosion. Example: mountain slopes erode faster than flat plains. To soil. Loose, sandy soil erodes quickly. Clay or compact soil resists erosion better. Example: riverbanks with sandy soil wash away faster during floods. Presence of vegetation cover. Plants and trees hold soil together with their roots. Areas with thick vegetation have less erosion. Example, forest protects soil while bare land erodes easily. Change in land use pattern. Human activities like deforestation, farming, mining, and construction increase erosion. Removing vegetation or disturbing soil makes it easier for wind and water to carry it away. Example, cutting down forests for agriculture often leads to soil erosion. In summary, erosion depends on natural factors, rain, temperature, slope, soil type, and human activities. Land use changes. Titled Effects of Erosion and Weathering. Number 1. Active for millions of years. Weathering and erosion are not short-term events. They've been shaping Earth's surface for millions of years. Weathering breaks rocks into smaller pieces. Erosion moves those pieces away using water, wind, or ice. Over time, these processes completely change landscapes. Number 2, reshaping landforms. Because of weathering and erosion, the shapes of landforms keep changing. Mountains become lower and smoother. Plateaus get cut by rivers. Plains expand as sediments are deposited. Earth's surface is never fixed. It's always being remodeled. Number 3, example, the Himalayas. Long ago, there was a deep sea called the Tethys Sea. The Indian plate collided with the Eurasian plate. This collision pushed up the land, forming the Great Himalayas. So what was once a sea became the tallest mountain range in the world. In summary, weathering weakens rocks, erosion carries them away. Together, they reshape Earth's surface continuously.